Good morning, YouTube. So I've been doing a little more testing on the cooling fan inside this TrippLite inverter charger. And one thing I found, which I should have probably tested earlier, that's the original fan, and it seems to have some issues. It still runs, and I'll cut in a video where I show testing this, but it doesn't run as fast as it used to. It's only pulling about 150 milliamps, and it's rated at 1.2 amps, and it seems to have trouble starting when you apply voltage. It sometimes runs and sometimes doesn't run, and I decided to pull this out to check it. I thought maybe the bearing here needed a little oil, so I pulled the label back and gave it a couple drops of oil, but I think there's a problem with this fan too. You can see I've got 13.2 volts on my bench power supply. It's pulling 150 milliamps, but that fan doesn't have enough torque to get going, and it's just barely moving air. It's not going very fast at all. So I don't know if winding is burned out in here or something, but yeah, it's definitely going really slow. I used these in my garden shed, bought a box of 5, and I have a couple left. So these are the same size fan, 120 millimeters, same thickness and everything. So we'll plug it in. I don't know if you can hear the air blowing there in the microphone. So luckily this is a standard 120 millimeter 12 volt fan. So I put a 120 millimeter 12 volt fan in its place right there, and I've wired it into the fan controller plug on the circuit board, and you can see right now it's not running. And let's take a look at the load. I'm running my upright freezer right now, so let's take a look at that. So there's the AC watts on the freezer, 130 watts, and if you look there, 1.4 amps. So I built this light bar several years ago as a way to do load testing, and I've got 4 sockets with bulbs, and each socket then has a rotary switch that I can turn them on and off. So for this test I have a 40 watt appliance bulb up there, and then I've got 2 60 watt bulbs there. If I combine that, that's 100 watts. If I do these two, that's 120. And then if I do these two, 120 plus 40 gives me 160. And then I can do 40 and 150 gives me about 190 watts. And then if I turn on 60 and 150, I can go to 210. And if I went farther, I could go to 270. And up to 310 watts total. But this is what I'll be using to load test the inverter, and I want to see when the cooling fan comes on. No fan right there. 40 and a 60 is 100 watts. Nothing there. I'm going to turn the 40 off, and here's another 60. So this is 120 watts. So I'm going to turn both those off, and then here's 150. And nothing there. So let me turn on 60, 120, this should be 160, yeah, 160 watts, and there's no fan. So I'll turn off the 260s, and then I'm going to turn on 150, so this should be 190 watts. And there's, yeah, 195 watts in fact, and no fan. Let's turn off the 45, I'll turn on a 60, brings us up to 210. Now the fan turns on. You get above 200 watts and the fan will turn on. That's what I've been seeing. If you're below roughly 200 watts, that fan won't turn on. The other thing that happens is, like when my freezer starts, the initial surge current or startup current is several hundred watts, maybe up to a kilowatt. So the fan will start running right away, but after about 5 minutes it will shut off because the load has dropped. So let me simulate that. I will drop down to 150 watts. So I turned off the 60 watt bulbs. And let's come back in a few minutes and see if this fan shuts off. Okay, here we are about 3 or 4 minutes later, and you can see the fan has shut off, and I'm still running the 150 watt heat lamp. So I dropped the current or the load below 200 watts and the fan went off. I can bring it up to 195 watts. There's no fan. So I'll shut off the 45, bring on the 60. Yeah, so now there's 212 watts. Oh, there it goes. Yeah, so right over 200 watts it'll turn the fan on. I was running the freezer last weekend and left this thing closed up. I had the cover on, and after about an hour or an hour and a half running 130 watts, the transformer was 58C. The heat sinks were over 50C on the temperature gun, which is pretty hot, and the fan definitely was not running at all. It started out running when the freezer turned on, but then after 3 or 4 minutes it'll shut off. What I plan to do, here's the cover for the unit here, and you can see I added a couple of PC board standoffs there, and here's my circuit board that's going on there. So one thing I've got on there is a pulse width modulated fan controller. It has a temperature sensor which I've screwed onto the heat sink, and then it can take 12 to 24 volt DC input, and it can drive 2 different fans, and you have a temperature adjusting pot there, and it's got 2 different modes. There's a switch there. You can put it into the fixed mode is 30 to 50C temperature range, and then the adjustable mode, which is down, uses this pot here to set your temperature threshold. I've got my power plug there. I'll put a switch, and then I'm putting a little voltage regulator here because I want to then add my Arduino remote on-off circuit over on the side there. But yeah, that'll be the next thing. So I'll basically be using this board to control the fan based on temperature. I think the built-in fan controller is working. So yeah, there's a couple of things that I don't like about that built-in controller. One is it doesn't monitor the temperature. It just goes strictly on the load, so the thing can overheat if the conditions are right, and it won't turn on the fan. The other problem is the fan is inside. It's in the middle of the unit, and when you have the cover on, you can't see if the fan is running or not. The only way you can tell is you can feel for airflow outside the unit, or you might be able to hear the fan if it's on high speed. And the fan will usually turn on right away, and you'll feel the air running, so you'll think everything's fine, but after 5 minutes the fan will shut off and you don't know that it shut off. And then while the inverter was making noise before, you couldn't hear the fan running because the inverter was making such a loud buzzing sound. So one thing I'm going to do with this has 2 LEDs. There's one for power, and then there's a second LED that turns on when the fan is running. I'll be able to see that the fan should be running. The fan I have here has a tachometer output, so I'll bring the tachometer output and have that drive an LED, so I should be able to see the LED, and the brightness of the LED should correspond to the speed of the fan. So that'll give me 2 readings of the fan. And then the last thing I'm going to do is I'll have an extra power plug off of there, and I've picked up this 12 volt thermometer. So it just takes power and ground. This will run from 12 to 24 volts. Got a temperature sensor there. Maybe stick that down to the transformer side so I can keep an eye on the temperature in there. So I'll have a digital readout of the temperature. I'll have an LED. The brightness corresponds to the fan speed. And then I'll have the thermostat status LED. So I'll have 3 things that I could check. So yeah, there we're down on the heat sinks. We're up around 40 C, and on the transformer, yeah, it's around 40 as well. So it's definitely warming up, and if I left this running for about an hour, it would probably get up over 50 C, and the fan would not turn on. I don't know if you can see right down there, I added the other temperature sensor on the side of the heat sink, so right in parallel with the factory one. Because the fan located in the middle is probably a very good place thermally for that fan to be, because it's pulling air in over the heat sinks and then it's blowing it out over the transformer. So that's actually a very good place. It's just that you can't see if the fan is running. You can't visually confirm that it's working or not. Anyway, I will try some of these things out, and we'll report back once I get my fan controller board built up, and we can try testing that and see how it works. I'll put any updates over here on the left hand side, and if you have any comments or feedback, post up in the comment section below. And as always, thanks for watching.